Alright, so today we are on lesson 414. Starts at problem 447. Alright, says you developed several strategies for solving equations and systems of equations. You've also focused on the meaning of a solution. In this lesson, you will have an opportunity to see how your strategies can be used in everyday context. You'll expand your understanding of solutions by applying them to systems. Okay. Or applying them to situations. Alright, Jamal and Dino were still eating lunch as they came to Algebra 2 class. Someone had left a book on the floor and they both tripped. As they hit the floor, the food they were carrying went flying across the room directly toward Harold, who was showing off his latest dance moves. As Jamal and Dino watched in horror, Jamal's cupcake and Dina's sandwich floated right on top of Harold's head. Jamal's cupcakes flew on a path that would have landed on the floor 20 feet away from him if it had not hit Harold. Dina's sandwich flew on a path that would have landed on the floor 24 feet away from her if it had not hit Harold. Jamal's cupcakes flew 9 feet higher, while Dina's sandwich reached a height of 6 feet before hitting her. Okay, so now, how tall is Harold? Alright, so a lot of you are probably saying, I have no clue. Okay, draw it out. Alright, so Jamal and whatever her name is, Dina. Okay, we're going to assume that they're both at the same starting point. So if you've got a graph, all right, it says we're going to start with, let's see, who do we start with? Jamal, okay? Jamal's, it starts here, and they're saying that if it would have continued on, it would have landed 20 feet. Okay. It also says that Jamal's went 9 feet high. So it went something like there and there. Alright. And then Diana's would have landed here. And hers only reached 6 feet. So we're going to say that's 6 feet. So at her highest point, it was about right there. And it landed there. Okay. Now, what we're trying to do is figure out how tall Harold is. Okay. Let's see. Jamal's cupcake. You just kind of got to find what you can find. Alright, Jamal's cupcake flew on a path that would have landed 20 feet away from him if it had not hit Harold. Diana's would have landed 24 feet if it had not hit her. Jamal's cupcake flew 9 feet high. So the question is, can you write the equations for these? All right. You kind of got to go back even a couple chapters, but Jamal, okay, we're just going to represent him by Jamal's equals -9 over 100 x minus 10 squared plus 9, and Diana's -124 x minus 12 squared plus 6. This should have been a 24. Now, so I'm giving you the answer. Now you need to work back. What do you think this 9 and this 6 are? If you said that's the vertex of both of them, That's right. Okay. That is the vertex of both of them. -10, -12. Notice that's half of that. Does that make sense? Okay, that's because it's half. Both of those are half of that. That's squared. All that's good stuff. Okay, so that would also be where your vertex is. So this x, your vertex is at 10, 9. Your vertex of this one is at 12, 6. Now the question is, what does this -9 and -124 represent? Well, that represents the slope, okay, of both of them. You could just easily make those positive. But if you put those in your calculator, you're going to see it. I'm not going to have a whole lot of the other stuff that they're looking for. This whole lesson, I mean, there's only, excuse me, there's only 3 problems in it for you really to do. So, I'm doing this for 2 reasons. One, I want you to have to work on this. But I'm giving you that. I want you to work through it now. Not really trying to just leave you hanging out there, but in a way I am. Because I want you to struggle with it. Again, these are your equations you got to get to. What I want you to focus on is how do you get these two? How do you get what would normally be considered the slope? Okay. All right, so now we're going to go on 448. Show you what I want you to get, all that kind of stuff. Okay. Write a system of equations to fit the situation below. Then solve the system using as many of the strategies as you can. How many solutions are possible? Your math class wants to collect money for a field trip, so it decides to sell 2 kinds of candy. The chocolate lovers bag costs $4.25. So whenever you get that, just write that down. Chocolate lovers equals $4.25. Okay, for 5 chocolate truffles. All right, so 5 truffles. So we need to put chocolate and 2 caramel, however you want to say it, truffle. Okay. The combusting caramel bag, so CCB is what we're going to call that, costs $3.50. For 8 caramel truffle candies, or turtle candies, I'm sorry. So 8, this caramel turtle, this caramel turtle, and 2 chocolate truffles. So we should have put this over here. I want to say those are turtles. Then you get 2 truffles. Okay, you've got a system of equations now. This one is a lot easier. How much does each cost? So they want to know how much does a truffle cost. Okay, we're going to say that is X. And they want to know how much a turtle costs. It's probably not how you spell turtle, but is that how you spell it? Turtle? Huh, I am right. So now we're going to say 425 equals 350 equals, okay, 5x plus 2y. This is going to be 2x plus 8y. Alright, so there's your systems of equations. Pause the video, figure out as many different ways. So before you pause it real quick, you've got graphing, you got elimination, you got substitution, and there's some other ones too that you need to work on. But those are the main ones that you need to be working on. And I just realized that handwriting is probably small again. Hopefully you can zoom in on it some. I'm trying to write bigger, but I just don't write very big. Alright, so pause it now, try to figure it out, and come back, and I'm going to show you the elimination, which is my favorite one. Alright, so elimination. What I'm going to do is multiply this whole thing times -4. Okay, so now I've got this, I'm going to pull this down just to right here. That's going to be -8y, -20x, and then 425 times 4 is 17, so that's actually going to be -17. Now you should be able to see how you can eliminate. Okay, so you've got 8y and -8y, which you're going to eliminate. So that eliminates. This becomes -18x. And then 17 minus 350 is 1350, and that's actually a -1350. Alright, so now I'm going to divide by 18x, or not 18x, 18. Sorry, divide by -18. So that gives me 0.75 equals x. So that tells me that a truffle equals 75 cents. Now I can plug that back into either one of these. I'm going to plug it back into this one because that's the smallest. Kind of running out of room, so I'm going to have to write it right here. Alright, so 350 equals 2 times 0.75 plus 8y. Alright, so that's $1.50. 350. I'm going to subtract $1.50. Sorry about the writing getting small, but I'm trying not to flip over so we don't lose all our work. So now I got 2 equals 8y divided by 8 divided by 8. 2 divided by 8 is 0.25 equals y. Alright, so there's that. Alright, so 449. Alright, 449, okay. It says, lucky you, you're a new college graduate and you've already been offered a job. Each job involves exactly the same task, but the salary plan differs as shown below. So we're going to write down these salary plans. It is $52,000 per year with an increase of $3,000. Okay. B is $36,000 with an 11% raise. Under which condition would job A be the better choice? When would job B be the better choice? Use graphs, labels, tables, and equations to help you justify your answers. So talk about it, okay? What it's really asking you is, at what point does job A, obviously the first couple of years job A is a better offer. But if you stay in it for how long, when does job B start to become the better one? So what we're going to do is what I would do, I would create a table. I would have years, I would have A, and I would have B. Okay, so this is 52,000. This is 36,000. Okay, now the other thing I would do is I would find an equation that works. Okay, so the equation for this is simply y equals 52,000 plus 3,000 times x. Okay, so essentially what you're doing is you're adding 3,000 for every year. So this actually needs to be year 0 because 0 times 3,000 gives you 52,000. So year 1, year 2, 3, 4, 5. We're just going to go to 5. All right, we're going to do this a little bit easier because we're only going that far. 58, 61, 64, 67. Okay, and we know that's 1,000. Okay, now this is 11%, so we got to find an equation. Really what we're saying is y equals 100.11 times x, or no, let's see, I've did this a couple times, 36,000 times 100.11 raised to a power, okay? That's what I want you to figure out is what power is that raised to? This is Algebra 1 stuff, but we're going to do it. Now, again, we only need to go about 5 years, so we can kind of make it this. We can do it this short way, so where we calculate it every year. But if we had to go 50 years out, then we need to know what that equation is. All we're doing is we're multiplying each one of these times 1.11. The reason why we have this 1 is because we want to include last year's salary. Because if we did it times 11, it would just tell us how much it increased every year. All right, so that number times 1.11 gives us 44,355.60 times 1.11 gives us 49,000. Now you can see you're already increasing by roughly 5,000, so you're going to catch up pretty quick. 54,650.53 times 1.11, 60,662.09 times 1.11, 67,334.92 times 1.11, 74,741.77. All right, this is at 70. This is at 73. So year 7. If you were going to stay at that company for 7 years, you would want to take B. If you're only going to be there, if you're only going to be there for 6 years, then you would take salary plan A. Now, if you really want to start figuring this out, look at the tax brackets and all that kind of stuff, and then if you want to take it a step further, start looking at the different tax plans that each presidential candidate is talking about this year, which I don't even know who I'm going to vote for this year, but one thing that it was interesting to me was something that I saw that talked about raising the minimum wage, and it said, right now you can buy a gallon of milk for whatever, $3.15. Okay, so if you've got $3.15 right now, if you make the same thing that a gallon of milk costs, then you can buy a gallon of milk for every hour you work. Okay, now obviously we make more than $3.15 an hour. But if you raised it to whatever number, let's say $15. Okay, well, what is the person that's producing this milk? What do they have to do to pay their employees? They're going to raise the price of that product too. They're probably going to keep it the same as if they keep that same ratio. Okay, does that make sense? So if it's costing them $3.15 to pay the person to make the milk or cook you something to eat or whatever it is, and we raise the minimum wage, okay, they're going to raise the price of their product by the equal amount, by the same ratio. Now, it may not be whatever they're fixing you or whatever product you're buying, may be more or less than that, but this is just a way to show it. Now, you more than likely went up in a tax bracket. So you were making more than $3.15. That was after taxes. Okay, so if they raised the minimum wage to $15 after taxes, okay, we're going to assume that this is after taxes. But what's going to happen if you are in this higher tax bracket? Or if you're making more, it's going to put you in a higher tax bracket, correct? Okay, so now it won't be on that particular day. You'll still be able to buy that. But when you get taxed at the end of the year, they're going to take more. So now you're making about $14. That same gallon of milk is now more expensive than what you make per hour after taxes, because after taxes you're in a higher tax bracket. I just thought it was an interesting thing, but this lesson was probably fairly quick if you watched it through, like second block usually does. If you're first block, then y'all are pausing it, figuring stuff out, talking about it. You're probably you're probably getting towards the end of class. All right, your homework 451 through 457, and I'm going to take up your homework at our next test, okay? So you need to make sure that you are doing it. All right, have a good day. I'm going to try, not promising you anything, but I'm going to try to be back next week. But also I'm going to try to get it set up so that we can have a video class, if that makes sense, so that there's a camera in class. I can call or Skype or FaceTime or whatever and be able to work kind of with you more one-on-one. I hope you have a good day, and we'll talk to you soon.